Let us prove that if z plus a is equal to a, then z is equal to 0 for all z and a element of the real numbers. We are still on the review of real numbers, and we are going to show here that this statement is true using the algebraic properties of real numbers. This is very important as we move closer to the topics on real analysis, where these types of ideas are very essential. So let's start with this proof. For the proof of this, we are going to assume, okay, let we have z and a element of real numbers, so that we will be able to apply all the necessary properties, algebraic properties of real numbers. Then we're going to show that from this left side, we will reach this right side using this idea and again all necessary algebraic properties. So we have here, then we will have here z can be written as z plus 0. Let me use this as my z. Okay, so I can rewrite z as z plus 0, and we know that 0, or adding 0, or 0 itself is the additive identity. Hence, we are not changing the actual value of z. We are doing this so that we could introduce another algebraic property of real number which focuses on inverses, because 0 being an identity can be a result when adding two inverses. And I'm talking about this. I can introduce here, since we have here a, I can introduce here a plus negative a. Okay? And that would mean that this 2 is actually just equal to 0 because they are both inverses of the other. And we are not changing the actual value of z. But we are doing this so that we can introduce this identity later, as we will apply associative property of addition. As we regroup this, z and the positive a, and then we have here negative a for this portion. This is the associative property of addition. We are doing this because we are already given with an hypothesis here that z plus a is equal to a, and then we can apply that further to show this target. That's our goal. Take note that z plus a, as hypothesized, is just equal to a, and leaving with plus minus a in this portion. I guess you could see already the proof of this, as we again have the sum or addition of two additive inverses, which will yield us the result of 0. With this as our left hand side, reaching this right hand side, we can now claim that thus we have here z is equal to 0. And this ends our proof, as we have shown the intended result. This really means that if z plus a is equal to a for all z and a element of real numbers, then z is just equal to 0. Thank you very much for watching.